Okay, let's get started. Good morning, good afternoon, good evening. Welcome all to today's event on decentralized identity for travel sector. I'm Shiv Agarwal, founder and CEO of Earth ID. Earth ID is an award-winning decentralized identity management platform that allows secure and frictionless exchange and verification of identity information. Earth ID helps organizations reduce identity frauds and save time and costs associated with customer onboarding processes while ensuring privacy and regulatory compliance. Earth ID empowers users with data ownership, privacy, and consent. I'm also leading Government Blockchain Association in Europe. GB is a global non-profit organization with over 120 chapters around the world and help public sector organizations and governments understand and adopt blockchain technology. Today, we are going to talk about how decentralized identity can help travel sector provide seamless experience to the travelers and other stakeholders while maintaining privacy. We have three brilliant keynote speakers today. Anil John, who is a technical director at Department of Homeland Security, US. Devjani Mohanty, who is a SSI expert and an author. And then we have Charles Walton, who's uh, Senior VP Digital Identity at MasterCard. Let's get started with you, John. Over to you. Please feel free to share the screen.
Sounds good, Shiv. Let me try that. All right. Is that working?
Yes, it's working.
All right. Let me also minimize this part. All right. Good morning, good afternoon, good evening to everybody. As Shiv mentioned, my name is Anil John. I'm a technical director at the US Department of Homeland Security. So my discussion here today, right, so is not just going to be on the travel sector. It's going to be a little bit broader. Glad to be talking with the Government Blockchain Association in Europe and the broad audience that is available here, right? So also I'm very happy to see old colleague Charlie Watson is also going to be sharing the stage here as well. So my focus is going to be a little bit of history as well as the work that we're doing in the space. This is both about the R&D work that the department has done over the number of years in blockchain, DLT, and DAG, as well as the work that we are doing when it comes to the VC verifiable credentials, decentralized identity ecosystem as well. So you can read the agenda faster than I can. So just want to give you a sense of what you are going to be hearing from me today. For those, given that this is a European audience, just a quick note. US Department of Homeland Security is an agency that has a pretty broad remit across everything from border control to emergency response to citizenship and immigration and a variety of other pieces as well. I work in the Science and Technology Directorate of the department, and our job is twofold. We are both the science advisor to the department as a whole and its missions, and we also are the R&D arm of the department. And me in particular, I work as a technical director in our Silicon Valley Innovation Program, which was a program that was set up about 5 years ago in order to bring in global talent from the startup community in order to solve our local problems. So we'll get into that a tad bit as well. So given that this is the Government Blockchain Association, let's start with the globally visible, bright and shiny object that is blockchain, right? So this was us 5.5, 6 years ago. Is the question that we were asking ourselves at that point in time, because what we were seeing in the market was the blockchain is going to solve everything. Blockchain technology is going to be, solving corruption in land title management. It is going to solve challenges when it comes to energy trading and a variety of different things. And our question simply was, the classic aspects of security, confidentiality, integrity, availability, that has stood the test of time. Does blockchain support that or does it not? Privacy aspects, selective disclosure, pseudonymous operations. Does blockchain support that? And there was not a lot of deep thinking going on at that time. The other point is as a large organization or as an enterprise, rip and replace of technology is not a path to success for us, right? So one of the things that we were trying to gauge was, what is the gain to pain ratio in looking at blockchain technology? Is the gain of adopting this technology worth the pain that we will encounter in integrating that with our existing technology and process stack? And if you're familiar with that term, it actually comes out of the venture capital community. And what it refers to is, if the gain to pain ratio typically is not about 10, nobody moves off of default, right? So we were really trying to figure out whether or not this was relevant to us. We are a law enforcement organization. So we also had a separate stream of work that was focused on anonymous currencies and anonymous networks. That is not something that I'm going to be getting into here, because our focus very much was on the blockchain as IT infrastructure at that point in time. Fast forward a tad bit. Again, you can see the dating on this, like 2016. We did a significant amount of research. Again, we spent a good bit of time, pressure, and attention on this. And what you saw at that time, and I would make an argument that this, even though the columns might change on what the infrastructures are, in general, there is no consistent set of security, privacy, interoperability defaults across any of the blockchain systems. And I think that has continued to hold true over time as well. You sort of need to look at each system in and of itself to understand its implications. We also spent a lot of time trying to figure out when one would adopt blockchain. And I will simply note, as somebody who spent about 5.5, 6 years as the blockchain R&D lead for the department, majority of the use cases that are being floated for blockchain technologies does not require any blockchain at all. What it requires is basically a good, solid dev team, somebody who actually understands hash chains and some sort of infrastructure that you can deploy those hash chains on top of. You don't need a blockchain. So we spent a lot of time sort of trying to figure out a rubric that sort of allowed decision makers to decide whether or not blockchain is even useful in their particular use case. And you will see this. We actually contributed this to NIST, and I am reliably informed that Gartner is now currently using some variation of that, of course, with attribution to NIST rather than us, which means that our ideas have gone viral, right? So happy about that. So at a high level, I think the two things that you sort of need to understand is that if there are not multiple independent organizations in play, that means organizations, not separate business units of the same organization, but multiple independent organizations with their own unique authorities, and they want to get together, and none of them want to be in a position where they want to actually own the infrastructure or own the data, then you might have a blockchain use case. Otherwise, we tend to be very conservative on this and say that there are better, more mature technologies that can be used for this. We also discovered at that point in time that there was significant amount of hand waving over architecture and design. There was almost a, let's just blockchain it. Let's just add blockchain to the mix and magic will happen, right? So, and we also discovered that there was a significant challenge when it comes to interoperability, that there was a desire for organizations in general to be the next Google, next Facebook, where they wanted to be the platform provider of choice, sit in the middle and extract value from it. And that was not a path to success for us, right? And there was also this mystical belief in the power of encryption as a privacy tool within the blockchain community, right, at that time. And what I'll say is that the concept of encryption algorithms by their very nature have a time to live. And you combine that with an infrastructure that is designed to be long-term, the combination of those two things results in a path that you don't want to go down, because sooner or later, your data that is encrypted will get exposed. So this is not a path to success for us as well. And folks who are in the identity management will understand this. Distributed key management at scale has been a problem, is a problem, will more than likely continue to be a problem. And hand waving over it, there was a significant amount of hand waving over that one as well. So for us, blockchain was an answer looking for a question. And there were a lot of people who were basically answering that question. Hey, we want to sound intelligent and innovative and forward leaning. So let's sort of jump on the blockchain wagon as well. For us, we are a mission-driven agency. So we sort of stepped back and thought about what could this be applied to? And some of the things where we've always talked about the fact that we need to design software systems to be resilient, to be operating under duress in a world where perimeter security is no longer a path to success. So does the decentralized nature of a blockchain or a DLT infrastructure provide any answers there? So that is one. The other one was on the business side. We are very concerned about these walled gardens that are being proposed by vendors, where, as I mentioned, everybody wanted to be the platform provider and wanted to extract value. And last but not least, we source our technology from the same place as everybody else, the broader global ecosystem, which means that we want choice in the solution providers that we want to engage with in order to solve our problem, right? So you will see that URL from 2018. It is part of a congressional testimony that our program gave. And these themes were very clear there. So we had to sort of decide how to make blockchain useful if we were going down that path. And when you sort of peel back the covers, what you sort of discover is that there are two dimensions that you sort of need to consider when you think about blockchain DLTs or DAG, that is storage and ledger. And as we all know, storage is a commodity these days. Databases, cloud resident data stores, content addressable networks like IPFS and a variety of others. Ledgers are also interesting, and they sort of fall into two broad buckets, right? Some ledgers that use some manner of consensus algorithm, and some ledgers that use some manner of Merkle tree proofs. I personally, we tend to, I do not know if this phrase actually translates well across the American European context. But we personally consider, or I personally consider, the discussion around public versus private blockchains and proof of stake and proof of work and a variety of other creative consensus algorithms that are out there to be a discussion that is the technical equivalent of wrestling a pig in a mud pit. Nobody gets out clean. The only entity that is happy is the pig. So for us, we sort of stepped back and just thought from the perspective that what truly matters in this particular case, at least to us, is two things. Political acceptability of the technical infrastructures. For example, if you're anchoring anything within a blockchain or a DLT infrastructure that is, for example, used pretty extensively in a dark web commercial trading activities, you have a problem if you're an organization like us, if you anchor something in there. The other piece of it that is critically important is we are very careful about the cryptographic primitives that underpin any type of systems, the algorithms and the primitives that are used for digital signatures, for encryption, for random number generation. Those matter. Those are things that truly matter to us, right? So I know this might be heresy when it comes to talking to the Government Blockchain Association, but our approach in this has been to make blockchain useful by making blockchain go away. And what I mean by that is by make blockchain useful by abstracting over it, by layering over it a set of openly developed global standards and APIs so that you are abstracted away from the specific implementation of both the ledger and the storage mechanism, right? So this was the insight that we came to in how we wanted to pursue this, because we were, again, very interested in that truly interoperable ecosystem and a mechanism that provides choice in the marketplace so that we're not locked into one particular vendor or a technology stack or a technical solution, right? So strategic approach, again, fundamentally, we are about ensuring choice in the marketplace, ensuring that that choice is actually a true choice, such that I can move off of one product onto the other, because all of them are using a common baseline of interoperable standards. So we took a long play here, and I'll touch on all of these and how we sort of did the pivot into what we are doing these days, right? So first and foremost, standards. If you're going to talk about interoperability, standards-based interoperability becomes very, very critical. So we actually made significant amount of investments in this. So this is something that I think you are all familiar with, given this particular community. Verifiable credentials at W3C, decentralized identifiers at W3C. What you may not realize, unless you sort of poke underneath the covers and you will actually look at the credits there, is that I'll relate a quick story, right? So back in 2016, as we were doing blockchain research, a group of people came to, I was at that point in time, the identity management and data privacy R&D program manager for DHS. They came to me, and you will recognize some of the names here. Two people from an organization called Respect Trust Network, Drummond Reed and Les Chasen. A gentleman by the name of Manu Sporny, who was at that time the editor of the JSON LD specification, and a gentleman by the name of Christopher Allen. So they came to me as a group and said, hey, we're sort of exploring this thing where we want to actually see if we can provide an identifier functionality that clearly separates the identification and the authentication of functionality. Is this something that is of relevance to you? And it was, because we are in the US dealing with the legacy of the Social Security number, which basically is something that was created in the 1930s as an identifier for a social benefit, but over time has been used as an authenticator, as a shared secret. And that has resulted in an ecosystem that is ripe with identity fraud. So the ability to clearly separate those two functions in a manner that was independent was very compelling. And so it is something that I funded at that point in time. And again, the verifiable credential specification was also something that we funded and championed as well. Now, these are new standards. These are new specifications. Why go down this path? I will make an argument as somebody who in a previous life used to run the certification and accreditation program for private sector identity services in how they can be used by the government, US government. I ran into a lot of different implementations of identity infrastructures. And whether it is a PKI model or a SAML or an OpenID Connect, the classic attestation provider model goes something like what you see on the left, right? You have an issuer or an identity provider that interacts with a relying party or a verifier in a manner that is mediated through a token, an authenticator, and you prove proof of possession with the relying party, and then that relying party and a verifier calls home back to the identity provider or the issuer in order to retrieve attributes about you that allow you to basically be granted access to a infrastructure or access to some service, right? So this was an interesting problem, and one of the challenges with this is that if you are an identity provider that is either malicious or curious, that phone home problem has a phone home to retrieve the attributes has some implications whereby if you're malicious or curious, you have the ability to track and place them across space and time. And that was a concern for us. And that is the primary reason I think that we funded and supported and championed the verifiable credentials data model standard because it broke that particular paradigm, right? And obviously in this model, you also had the specific requirement in how do you uniquely identify a issuer or how do you associate a issuer, excuse me, let me tripping over my tongue here. How do you associate an identifier with an issuer, a holder, or a verifier? And that is where obviously decentralized identifiers came in, which provides that clean separation of authentication and an identifier, right? So I am amused, as somebody who works for a sovereign, I am amused by the self-sovereign, and I know that Kalia is online as well, and we've had this conversation before. I am amused by the techno-utopianism of the broader SSI community. And I point to Kalia as somebody who has actually written a book on SSI and somebody who's actually been around for a long while. And I've seen the evolution of everything from all the technologies that we're talking about, right? So we tend to be, much more focused on the actual aspects of what DIDs and VCs bring to the table, rather than the techno-utopianism around the SSI model more than anything else. So how does this tie into and square with our blockchain DLT R&D? It's that very simple. In the verifiable credentials data model, there is a component called a verifiable data registry that could be implemented using a variety of technologies. It doesn't have, it can be implemented using a variety of technologies, but within the DHS infrastructure, if you are using a blockchain, a DLT, or a DAG, we have expectations, clear expectations that we expect that to be implemented using the model that we are focused on, which is layering over that abstraction of standards and APIs in order to provide true interoperability so that we're not locked into a particular platform. We are pleasantly surprised by the massive global support in one way, shape, or form for this particular model. Everything from DID Ion, which was recently announced by Microsoft as a production platform that combines IPFS as a storage mechanism with Bitcoin as the ledger, to one of the companies, and I mentioned this one because Charlie Watson, when I knew him, was actually the CEO of a company called SecureKey. And SecureKey is one of the companies that is focused on this one. They actually have an open source implementation called TrustBlock that combines Hyperledger Fabric as the ledger and IPFS as the storage mechanism. And I have some other companies in my portfolio that are using other combinations as well, right? You can see in the MongoDB Verus one and the AWS S3 QLDB as well. Again, a lot of support for this layer of abstraction over both storage and ledger mechanism. And obviously there is a attendant set of standards and technologies that are important when it comes to these implementations that we are obviously focused on. We can talk about that if you have any questions later as well, that are being standardized both through the IETF and W3C. So it's great to have standards. It's great to make investments to sort of understand the gain to pain ratio. But you actually need to go down the next path of actually doing the hard work to understand whether the standards can actually work in the real world. And that is where our partnership with the US Customs, which is a part of Department of Homeland Security, came into play. We actually did a series of proof of concepts that tested out the implementation of these standards and specifications in very, very realistic POCs that dealt with international trade, intellectual property assertions of imported goods, and a variety of others. So there were some specific lessons learned. Those PDF links, and you will be getting a copy of this briefing. So if you click on it, you will actually see the actual full report from CBP that talks to the lessons learned from that as well. But the long and the short of it is, proof of concepts are critically important in order to inform whether the things that you're thinking about standardizing and how to standardize are indeed working in the real world. And what it ended up for us was something critical. It was an acknowledgement and a policy decision by US Customs that if you are an organization in the global trade ecosystem and you want to basically connect to US Customs in order to provide data using a blockchain, DLT, or a DAG technology, you will use these standards and specifications, right? So for those who are not familiar, US Customs, the largest customs organization on the planet, if you are moving goods into the US, you need to talk to them legally. You need to provide them data about what goods you are moving into the US so that they can basically do an assessment of yes, no, we want to talk to you more, right? So when the largest organization in the face of the planet puts this type of stake in the ground, it matters. Now, we've done the R&D, we've done the proof of concept. We were at a level of comfort where we actually were in the position where we wanted to actually apply these technologies to actual problems that we wanted to solve. And that's where my program came into play, right? As I mentioned, we were, I'll cut short, you can go and check out our website, but we are an organization that basically is in the business of finding global talent to solve our local problems. We are one of the few organizations within the US government that actually have the ability and the capacity to fund international startups and not just US-based startups. And we have a very structured mechanism whereby we reduce the risk to our operational components through a phased model, whereby phase one is a minimum viable product that shows the application of these technologies to solve this problem. Phase two is the full capability built out. Phase three is when I throw a red team at the company in order to understand their security and privacy and interoperability implementation. And phase four is where we give them an option to operationally deploy this technology. Again, this is not a R&D program. This is shaping product in order to solve the problem. And we also do a couple of other things. We are not a grant-based program. We are a contractual deliverable-based program. So if you want to get paid, you deliver on the things that you committed to. And you do one other thing. We multi-track. We fund multiple companies to solve the same problem because we have discovered that diversity of thought, diversity of life experience, diversity of how you approach the problem has a bearing on the commercial traction and the way you address the solution itself. So in 2018, we put out a solicitation that basically was addressing the needs of our US Citizenship and Immigration Service and US Customs and Border Protection. I'm particularly pleased that those two organizations out of the three are organizations that are older than DHS. In fact, they are as old as America itself. So the fact that they were leaning forward on this was a particular source of a joy to me. Again, our focus was around citizenship and immigration status, employment eligibility, essential work and task licenses, and supply chain traceability, right? So we put this in, and we also applied the lessons learned from our R&D and a proof of concept into our solicitation. Because interoperability, the desire not to be locked into one particular technology stack or a vendor was critical and paramount. And when you talk about interoperability, you can consider it across three different dimensions, right? The pipe, the payload, and the policy. The pipe that basically defines the protocols that exchange information, the payload that defines the data in some manner, and obviously the policy that sort of wraps around all of it. In our solicitation, we had a hard requirement that we have been in a position as an organization where we've been walked into a corner by vendors who have licensed APIs and told, if you want to solve this problem, you gotta buy into that. Our requirement here was that all APIs that were facing both an issuer of an attestation and a verifier of an attestation needed to be open, royalty-free, non-discriminatory, free to implement by anybody. We were perfectly comfortable with somebody building value-add services behind or on top of these open APIs, but we would not in any way, shape, or form want to be in a position where we would be locked into those APIs at the foundational security, privacy, and interoperability layer. Payload, we required the companies that would be working with us in order to support the standards and specifications that we had explored, invested in, and were championing going forward. And last but not least, from a policy perspective, we expected the identity verification component between a holder, a wallet, and a verifier to be, at a minimum, have an authentication assurance level of 2 or greater. It didn't matter what that technology is, but the assurance level did matter. And of course, these are technologies that will be connecting into our government network. So we expected that the cryptographic primitives that are being implemented by these companies to be able to support the Federal Information Processing Standards as defined by NIST for hashing, encryption, digital signatures, random number generations, and the like, right? And a couple of other things, right? This is not a problem that we considered that we could solve as an agency, as a government. It is something that needs to be worked on in the open with a global community of people who are seeking to solve the problem. So we also made a commitment, and we required this of the companies that we funded, that any work that they do in this space, any test suites and test tooling that they build in order to ensure interoperability, it does not reside with them, does not reside with us as DHS, but actually resided under the umbrella of the W3C's credential community group, so that it was freely available and usable by anybody. Anybody could contribute to it, anybody could use it, and it became a public benefit and not just a benefit to us or just these companies, right? So this was a contractual requirement. So as somebody who has been in the certification accreditation space in a previous life, I am not a believer in the self-attestations of interoperability. So interoperability, we have hard requirements on how you demonstrate true interoperability. First and foremost, we expect you to demonstrate standards compliance against the standards that we just talked about and required, right? So we expected the development of automated test suites under the W3C CCG so that it was globally available and usable and contributable and leverageable by anybody, as well as us. And we want those automated test suites to be developed by these companies. We are funding them to develop it for our purposes and for the public interest as well. So we will use those automated test suites in order to ensure standards compliance. That's not enough. The problem with standards is very simple. Standards are created by people, which means people have to make compromises when in the development of a standard. So there is often different ways of implementing the same thing or different ways of representing the same thing in the same standards. How that plays out in a practical bit is that two companies, two organizations could implement a standard and be fully standards compliant and be totally not interoperable. So in addition to standards conformance, we require, and we brought this back from our WSR, SAML days, an interoperability demonstration, a plug fest, where we bring these companies together and you do end-by-end matrix testing across all of them to ensure that they're not just standards conformant, but truly, truly interoperable across a multiple set of dimensions. This is a contractual requirement for our companies. Now, fast forward here. We are fortunate in that that solicitation I showed you in 2018 resulted in us, as I said, we also multi-track. We fund multiple companies in order to solve the same problem. They sort of can be bucketed into two broad categories, what I'll call digital personal credentials, that that is the issuance of immigration credentials like the permanent resident card, certificate of naturalization, employment authorization documents, vaccination certificates, and the like. And on the US Customs side, trade credentials, certificates of origin, attestations of organizational identity, and a variety of other things. As you can see from the company portfolio that we are truly in the business of finding global talent to solve local problems. There are, out of the 8 companies, I think we have 1, 2, 3 companies that are actually US based. The other 5 are actually all over the world, from New Zealand to the EU to Canada, right? So we're very happy with them. And they were also, we are very happy that they're also grown-ups, that they understand the value of working together on a common baseline of security, privacy, and interoperability, and fiercely competing on the value-add services that they build on top of it. And so I mentioned the Plug Fest. We had our first one back in May of 2020. All of those things that we tested as being interoperable. I believe that was the first time that anybody had actually demonstrated multiple blockchain and non-blockchain infrastructures actually interoperating in any meaningful manner. We recently had our second Plug Fest last month, where we got to a point where we are comfortable as a fully capable enterprise-ready solutions, and we expect this to continue on with specific feature sets as well, right? So, as I mentioned, we basically require. This is not self-attestations of interoperability or anything like this. We actually have test suites under the W3CCG for the VC HTTP API that basically allows you to test credential types, signature schemes, DID integration, method, and resolution using an open test suite. It is available to anybody. So for folks who are interested in that, you are free to contribute. You don't need to ask permission of anybody. Go forth and use it, contribute to it, leverage it. This was a contractual deliverable, the results of it to show the demonstration of standards compliance here. We also had test harnesses that focused on CHAPI, Credential Handler API, interop testing as well. And finally, vocabularies are important. So we actually work out on the vocabularies that are being used for the supply chain cohort. They are working on a traceability vocabulary under the W3CCG that identifies the set of electronic attestations that are being used in the trade community. Vaccination vocabulary that is actually leveraging what WHO's release candidate 1 data model and above, and a variety of others that are in there as well. And last but not least, we actually had to demonstrate, as I mentioned, contractual deliverable demonstrating multi-party true interop in a Plug Fest. So we used a particular scenario to drive this through of the journey of Louis Pasteur from getting vaccinated all the way to becoming a naturalized citizen, where you had multiple parties that are part of our portfolio of companies interacting with each other, both in a variety of different roles, as an issuer, as a verifier, as a wallet provider that showed true multi-party interoperability. You can see some slides and everything from there, as well as some videos of those interoperability Plug Fest at that link that is there. So this is on the personal credential piece here. We also did the same on the digital trade credentials. You will see, we were focused on the import of steel, e-commerce, agriculture, and oil and natural gas into there. And we basically did the same thing, a scenario to drive N-by-N testing of these capabilities to show true on-the-ground interoperability and not just attestations or self-attestations of standards compliance. So I will leave you with a couple of final thoughts here, right? Real interoperability in this space actually requires constraints. Basically, you cannot support everything under the sun. Our focus when it came to the use of W3C, VC, and DID standards is that for us, the data model of choice was JSON LD, right? So because it provides a variety of extremely important benefits, everything from semantic parity to an extensibility model that is based on RDF that is completely standardized. We are big believers in selective disclosure because that is a clear driver for us. We also want that selective disclosure to be implemented in a manner that does not lock us into any particular ledger. So from that perspective, we are champions of linked data signature-based selective disclosure mechanisms, and we are focused on the BBS plus signatures as the mechanism, which brings pairing-based cryptography to provide selective disclosure that is under the control and consent of a holder. And last but not least, refresh and revocation are critically important for us. We need the ability to refresh credentials. For example, if a permanent resident card needs to be extended, the expiration of that needs to be extended, there needs to be a mechanism to do that in a manner that is seamless for the holder of that PRC. This applies to things like vaccination certificates. We currently do not know the science behind how long a vaccine is effective. So the ability to refresh that end date as science becomes more firm on that is critically important. Revocation is critically important, and revocation needs to be done in a manner that does not compromise the phone home issue. Right, so that's something that we clearly support in that. We support revocation checking only that is in a manner that is initiated by the holder and not by the verifier, because the latter bypasses the holder and their consent and knowledge. So a couple of things, right? So real interoperability matters and it can be done. We've been doing this for 6 years, and I am amused by the people who sort of suddenly got the interoperability religion and want to start up working groups in order to develop what interoperability means. We've demonstrated it. We have the test suites that anybody can use in order to use it to verify interoperability. We also believe that you cannot just rip and replace existing infrastructures, right? You need to be able to integrate with them. That is critically important. You need in the credential space, we are a government entity. We do not have the luxury of choosing a digital only solution. So that we need bridge to paper. We need the ability to verify technologies across the board here. And there is a clear role for government in this space as well. There is definitely work that continues to be done in this space, and we are working on that, and happy to chat about that at a future time. And last but not least, one of the questions that I'm often asked is, why don't you just put contracts into place? Why are you working out in the open? 2 or 3 reasons, right? So this problem, solving the problem, this is not R&D for us. We are shaping product in order to implement this technology internally for our operational components. So it is a DHS priority for us. There is a need in this technical community in order to have a broad standards-based interoperability going forward. And we are a public entity. So the work that we are doing needs to be in the public interest. So the when of those are, we feel that that's a reason that we are doing in this manner. So that's sort of the journey of where we are. I'll defer to Shiv and the rest of the organization on how if there is any Q&A or anything like that. But for right now, let me stop sharing on this one and turn it back over to Shiv.
Thank you very much, Anil. It has been very, very informative, and I'm already receiving messages about how detailed and how informative and useful this has been. And I think because you have presented a very detailed perspective with respect to standardization, with respect to interoperability, and in general, the involvement of government and public organizations. So thank you very much for your presentation. And to basically maintain the time, I think we would have to defer the questions, but what we can do is we can ask the audience members to email us the questions, and I would happily share those with you, and then we can address them accordingly. For our next presentation, we have Devjani Mohanty, who's a SSI expert and an author, and she works very closely with Earth ID. She has happily recorded the session for us to ensure that there are no technical challenges. So I would play the video, but Devjani is there in the audience, and you can ask any questions that you may have, and she would happily address those. So let me go ahead and share my screen and play the video. And please let me know if you can see my screen, and I can just play the video. Tracy, can you please confirm whether my screen is visible? Okay, good. So I'm just playing it now.
Good morning, ladies and gentlemen. I welcome all of you to this session on decentralized identity for travel sector. A quick introduction regarding myself. I'm Debjani Mohanty, SSI expert at EarthID. I'm quoted as one of the top 30 blockchain influencers of India 2021 and blockchain catalyst of India in year 2019 and 20. I'm a solution architect working in blockchain for past 5 years, and I'm also author to 5 Amazon bestseller books on blockchain, some of which are translated to German and Chinese to reach the wider mass. For the past 2 years, I'm working in blockchain-backed decentralized identity, and my latest work is on decentralized identity or self-sovereign digital identity. With government-imposed travel bans and nationwide lockdowns, 2020 will go down as the worst year in the history of modern-day travel and aviation industry. In this slide, you can find how negatively COVID-19 has impacted the stock prices of cruise and airline sector, and how much the US travel industry has lost in this time period. Nonetheless, 2020 has accelerated digitization and automation of many aviation workflows. Today, increasing passenger safety, boosting passenger confidence, and making airport and airline operations significantly more efficient, adaptable, and intelligent is the new blueprint for survival and growth. In today's session, I would cover the inefficiencies in travel sector, especially in COVID times, certain innovative use cases with self-sovereign identity or SSI and biometrics, and EarthID's state-of-art architecture that can cater to the need of travel and especially the aviation sector. For this session, I have selected airlines and airports. Why? Because we professionals mostly use flights for traveling to places and moreover in order to save our precious time. For example, I live and work in Delhi NCR, and at the back of my mind, I always have the thought that my hometown Bhubaneswar is only 2 hours flight from Delhi. But how far that is true? If I add all the time needed by me to travel door to door to my parents in Bhubaneswar, it's close to 6 to 7 hours. And most of this time I spend either in queues or in waiting. So airports across the world are getting busier every year. Traveling as an experience is always chaotic, inefficient, unenjoyable, and unsafe. Can someday in future we can overcome all these challenges and make these processes streamlined, safe, and delightful? Let's find out. From the moment of passenger journeys to a departure terminal, they are faced with a series of small but potentially stressful challenges. First finding the parking, then finding the baggage card, finding the correct departure terminal, finding the check-in desk. All the while, the passenger might be wondering if they will make it to the departure gate on time. So here is a typical wait time that an airline passenger experiences during the air travel. Perhaps 10 minutes at the check-in, 20 minutes at the security check-in, again 10 minutes in the immigration, if it's international travel, and then 30 minutes in the waiting lounge, and then few hours of flight, again 30 minutes in the immigration, 20 minutes at the baggage collection, and finally exit. Each step in this journey could be frustrating. However, the number I have shown here could be far too less. In bigger airports, this number can be painfully much more. In US's Newark Liberty Airport, the security check-in can take up to 60 minutes. In the right-hand side, you can find the number of passengers leaving the airports in US in every 15 minutes. The maximum number you can find in US's O'Hare International Airport, which is 485 passengers in just 15 minutes. In this slide, you can find that there are certain areas in the airport where we find either full or partial automation. For example, booking, bag and check-in. However, there are areas where manual intervention is high and the processes are relatively slow. For example, the security check-in and passport or border control. Obviously, you can find that the customer satisfaction is far too low in areas that are yet to be automated. Have you ever wondered why air travel is so time consuming, and even if it's so, can these processes be streamlined? In this slide, you can find all the touch points of the journey where the user's identity is checked again and again. For example, booking the ticket, checking in, bag drop, security, border control, and finally boarding. Now, let's see how the data related to the digital identity are stored and maintained in the existing systems. The first model that came some 3 decades back was the centralized server, where we used either LDAP or Active Directory or RDBMS to store a separate set of user ID and password for each application. The second model is the federated identity model, where we used a separate identity provider that has a centralized storage again for storing the credentials, and it handles the access to several third-party services. So in both these models, there is a possibility of mass hacking as well as single point of failure. Self-sovereign identity, or SSI, is a new decentralized model to manage digital identity. Here we have an issuer that issues verified credential to the user that is saved securely in the user's mobile device. At the same time, the issuer sends a signed reference hash to the public blockchain, signing it with their own private key. The user then can share the whole or part of the data to a verifier organization along with issuer's public decentralized identity. Now the verifier can convert the data to a hash and check if the hash of the data matches with that on the blockchain to know that whether it's valid. This example can be a scenario where the issuer is the passport office and the verifier is the visa office, and the user is sharing as much data needed by the visa office with the user's own full consent. At a later point of time, if there is a need, then the issuer can revoke the hash by altering a small piece of the data, and the verifier knows that the data is no longer valid. This architecture ensures integrity, ownership, privacy, security, and the validity of the data. And please note that in this architecture, there is no centralized data store. SSI in real life is far too complex. Let's say that Alice is born in a hospital. So the first set of verified credentials you would receive from the hospital. Now she applies for her national identity. And so the government is approving and allocating the national identity. Then she is producing both these credentials to a school or a college where she goes for her education. And on completion, the university is again issuing one more set of verified credential to the user. And finally, she is joining an organization as an employee where she has to produce the certificates from all the previous issuers. So all this kind of verified credential can be allocated, and she can safely secure this in her own mobile device. And as per the need, she can share this information with different verified organizations. And she can also share this information, this personal data, in 3 different modes, which are the traditional mode, generalized proof, and the selective disclosure mode, and self-attested mode. In traditional mode, I'm sharing my name as it is, that is Andejani Mohanty. In generalized proof mode, I'm just answering in true or false. Like somebody is asking me that whether I'm an adult, I'm just replying saying that it's true, and it can be verified. And the third is the self-attested one, where you do not need to get a verified credential for anyone. You are sharing it this data on your own, something like your hobby or something. So again, these data are, actually the hashed version of this data is available on a public blockchain. So this hash is created and stored by the issuers, and the verifier can check the validity and the integrity of the data on the public blockchain. Again, I'm telling you that actual data doesn't go to the blockchain, but a hash of the data goes to the blockchain. The SSI ecosystem is usually pretty complex, where we have to handle the web standards, the authentication standards, the blockchain, and the decentralized network. In SSI network, we have to handle many different layers. At the center, we have a public ledger or a blockchain. Then there is a private identity storage for each user or organization. We have an agent or hub for message transfers, as well as to replicate the data. And we have to handle a client device for each user. Ecosystem of a self-sovereign identity network is not limited to only data sharing. How do you get access to such a system? How do you save different type of personal data? Well, for an individual, it's the mobile device or IPFS or cloud storage. However, if you have to store the biometrics data, it has to be saved only in the mobile device, whereas the other data can go to the IPFS or can be stored in an encrypted manner, either in the device and on the cloud storage. So here you can see that Alice has got all her personal data saved in her own mobile device. So this personal data can be verified credential, which are alphanumeric in nature, like the name or date of birth, blah, 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 as well as the biometric templates. Whereas Bob has his data stored in his mobile device, as well as a copy on the IPFS or the cloud storage, so that if the mobile is broken or stolen or lost, then he can retrieve all this information again from the storage. For an organization, the data can be stored on the cloud storage. And again, we have a public DLT, which is responsible for the creation of the decentralized identities and reference hash of the claims. And also here, we are able to do any kind of revocation if needed. Now it's time to explore a travel-based use case. In this use case, the user has a smartphone running Earth ID's app on it. The user already has passport, visa, and biometric details verified and saved as verified credential in digital form. Now the user visits the airline's website for booking ticket, producing passport, visa in verified credential form. The airline asks for COVID test result, and if the user doesn't have it, Then the airline redirects the user to a couple of labs from where the user can get tested for COVID. Now the user visits the lab and get himself or herself tested for the COVID. The lab shares a verified credential with the user that the user can save in the mobile phone. The lab also writes a hash of the VC to the blockchain, signing it with own private key. Now the user visits the airline website again for booking the ticket, and now the user can produce passport, visa details, and the COVID test results, and also can share live biometrics. The airline checks all these details and matches with user's face that is there in the passport. And if the payment is through, then the airline can send a verified credential to the user's mobile phone, which is the ticket, the digital ticket. The airline also writes a hash to the public blockchain, signing it with its own private key. Now comes the day of travel. So as soon as the user enters the airport, the user shares all this verified credential with the airport server. Now the airport server checks the hash of the verified credential on the blockchain, and if it matches, then through cameras, the airport server can also match the face biometric template of the user with the one that is on the verified credential, and also matches the hash that is stored on the blockchain. And if all valid, then the check gates can automatically sense it from a distance, and they can open it for the travel of the user till the check gates. So the user doesn't have to showcase any of the physical documents in any of these touch points. So the advantages of this model are many, and here the governments can verify the authenticity of the test and can also identify the people who are tested. The airlines have the ability to provide accurate information to the passengers and on the test requirements. And the laboratories have a means to issue a digital certificate to the passenger that is recognized by the governments. And the travelers have got all the accurate information on test requirements. They're able to know that who are the labs who can get them tested and from where they need to be vaccinated. So all this information can be shared in a safe way and with utmost privacy and security. Now let's explore some of Earth ID's area of research. The success of a SSI product depends on many different factors. So the first is what kind of crypto or what kind of public key infrastructure we are using so that we can have a safe and secure data transfer. Secondly, what is the scalability and throughput of this model? Can it cater to the needs of millions, if not billions, in the future? Because we all know that this decentralized identity is for the general public and their devices. So we need high scalability here. Third is the cybersecurity part handled efficiently? And then is the solution interoperable? Can it be integrated with other decentralized identity network effortlessly? Then what kind of selective disclosure or zero knowledge proof model has been implemented here? Is it robust enough to compare different type of integer values in different modes? For example, greater than, smaller than, not equal to, etc. Very important factor here that who are the validator nodes. So here, please note that the public blockchain that we will be using in a SSI network needs to be very different from that in Bitcoin or Ethereum. The consensus model here should not be proof of work as Bitcoin has or Ethereum one had, which is slow and expensive. What we need over here is either proof of stake or proof of authority. or something similar, so that the transactions are super fast and highly scalable, and they can cater to the need of millions and billion people and their devices. Hence, the validator nodes or the nodes responsible to handle the consensus process and approve the transactions had to be run by organizations who are well known in the industry. And finally, how efficiently this SSI network is integrated with biometrics, that also is very important for the success of this network. Mostly because we won't give access to the SSI network on the basis of the same old school user ID, password, or OTP models. Biometrics is the best solution over here for the authentication purpose. So this also plays a very important role. So now let's explore one by one all these features from the Earth ID's point of view. Earth ID uses SHA-256 based hashing and novel ED25519 public key signature system, which is the fastest and safest at the moment. Earth ID is backed by the Hashgraph DLT, which is well known for its scalability and throughput. And Hashgraph is already tested with 10,000 transactions per second and up to 6.5 million transactions per day with finality within 5 seconds. Earth ID uses Hashgraph DLT, which is resistant against DDoS, Sybil, and spoofing attacks. Earth ID is working on integration with other DID networks and with other layers as per the requirements of business. Earth ID SSI network can share data in traditional zero knowledge proof or self-attested modes. Earth ID uses finest homomorphic cryptology algorithms for comparing integers in zero knowledge proof mode. For example, we can compare integers as greater than equal to, less than equal to, greater than or less than or not equal to modes to find out a Boolean as an output. Earth ID uses Hashgraph that has a council of 19 multinational corporations from around the world to govern the platform and the software that will run on millions of nodes globally. To reach the consensus, instead of mining or proof of work, nodes on Hashgraph gossip with each other, comparing nodes on the transaction history of the network. So Hashgraph's validator nodes are industry leaders in different verticals as Google, IBM, Wipro, Deutsche Telekom, FIS, Tata Telecom, etc., who are the organizations that the industries can trust. Hashgraph is currently integrating with biometric solutions from the leaders in the industry, and we are working on modalities like finger, face, and iris. And in future, we also have plans of integrating with behavioral biometric solutions like gait, voice, signature, etc. And we are extensively working on the decentralized biometric experts. So at Earth ID, we are on the process of building a state-of-art architecture for self-sovereign identity. And we are investing on all the different features and so that we'll come up with the industry-leading solution in SSI. So here is Earth ID's state-of-art architecture that uses Hashgraph as its public DLT. So users have the option of storing their verified credentials such as name, date of birth, educational certificates, employment certificates, salary, vaccination details, etc. in their mobile device with the help of Earth ID app running on their device or even on a personal laptop. User can also save their data on IPFS and get a printed copy of their data in the form of a cryptograph or QR code. This is especially useful for people who do not have a smartphone, or elderlies, or those who cannot efficiently operate the app on their device. So with EarthID, we can create decentralized identity not only for humans, but also for their mobile devices and IoT-based machines that can communicate and share information with utmost safety and security. So thank you so much for watching this video. If you want to know more, then you can contact EarthID. You can directly write to me on LinkedIn, and you can read my book, Blockchain for Self-Sovereign Digital Identity, which is publicly available on Amazon.
Okay, so with that, the presentation from Devjani concludes. Please feel free to ask any questions in the chat. Charles, over to you. Please feel free to share your screen and let's get ready with your presentation.
Shiv, thank you very much, and really do appreciate the invite today. I seem to require permission to share my screen. Hello, Shiv. Could you transfer permission to share my screen?
Charles, you should be able to do that now, actually, if you can try, because the Tracy, who's the admin, she has done it. Can you please try once again?
Yeah, it's not working properly, Shiv. I'm very sorry.
Okay, let me do one thing. Let me open your presentation at my end. Did you make any changes from the presentation that you sent?
No, you can go ahead. You can go ahead.
And sincere apologies for this issue.
I apologize to the group. And first off, Shiv, I really want to, while you're doing that, thank you very much for the invite, and for the two prior speakers, Anil in particular. It's good to connect up after a lot of years. I'll begin and really verbalize first off that MasterCard in this field of digital identity, as Shiv has probably mentioned, I'm part of a group called CNI and MasterCard, focused on the development of digital identity services in a broad-based way, not only for payments but for many other markets. MasterCard, as you are aware, is known for payments, but we see the topic of digital identity extremely important. Obviously, we've operated historically to quite a collaborative model of bringing together merchants, financial institutions, governments, and tech providers into an integrated whole. And so when you really think about MasterCard, a big part of our DNA is working collaboratively with multi-party governance. And when you think about that topic of governance amongst parties is really quite essential as we proceed forward with digital identity services. The company certainly knows a little bit about running billions of transactions at scale with 50 million merchants and 25,000 issuers really around the globe for the benefit of nearly 3 billion people. This initiative related to digital identity was kicked off by our CEO, Ajay Banga, who's seen a real commitment not only to financial inclusion, but also the importance of bringing people back in control of their data, and a very key precept associated with what we're really often doing. On slide 3, as Shiv is bringing this up, and thank you, Shiv, we see really what's called ID service. This is the system that MasterCard has deployed to date. We've got work going on in several markets, from Australia to the US to places in Europe. It is a decentralized, collaborative model. It's really important to note that MasterCard no way holds any data in a system like this. We're in essence operating a scheme and as a governance authority. This has been implemented to W3C verifiable claims, all supports OIDC exchanges. So this is not fully up to standard sets that Anil has described. And we've done that as we got going in 2017 to really start working and delivering value as standards were really evolving. Dealing with rich policy management is exceptionally important in a network like this. So that is the selective disclosure of information to say I'm a live human being, I'm over 21, or here are my COVID health pass details are really very different things. And this policy management tool is really helpful for that. We've taken a view that is multi-wallet. So this is a network-oriented play. And you can see here, and I'll also include in the chat, information about this service at idservice.com. This is going to be we'll say a long journey for MasterCard, quite committed in the sense that we do begin to see digital identity becoming kind of key rails for a lot of what we do moving forward. So with that, I'd like to maybe move on and jump into the kind of the key point here, which is really on slide 4 in the area of Health Pass ecosystem. We began to really look at this topic right about this time last year, and we begin to see what's an incredibly complex ecosystem if you began thinking about the simple matter of communicating Health Pass, which by its definition is much broader than the notion of vaccine or terms we've seen in the press around vaccine passports. So if we think about a health pass, really the information to communicate to those that are verifying information about a passenger, about Charlie, and that may include information about vaccine status. It may include health testing information about immunity through other types of testing that's gone on. So in essence, we think about a system model where health organizations, whether they be a public health administrator, a vaccine provider, a retail provider, or a health provider, a public provider, and then health test administrators. These may be in my clinic in the US at a CVS or at a Boots Walgreen, or at an airport kiosk, right? So many types of health credential issuers around the globe. Really the notion of a traveler who's in control, controlling their information, and those credentials in the form of a pass, typically provided off to the air travel industry. And this has got complexity in the sense that we've got governments now setting rules about entry. So if I come from country A and I'm going into country B, what are the rules for entry? Well, it may mean today that I have vaccine of a certain type or a test of a certain type and of a certain period of time. And these policy oriented rules that governments begin to set will be very likely swirling and changing as we work our way through what is hopefully a downslope on the pandemic, a pandemic that's not over and is going to be with us for some time. And so this notion of what we see, an issuer, a traveler as a holder, a verifier in the travel industry, either a government at a border, an airline themselves, or an airline system, a pre-departure control system, really being the key actors. And when we think about this, of bringing health, identity, technology, government, airline communities together, these are communities that in large part have not gotten to interoperable solutions, out over time. Now, a really important matter here are the material or the points down below. So the first thing is really the notion of an issuer registry, or a mechanism to confirm that the Mass General Hospital in Boston in the US or the NHS in the UK are really appropriate issuers of credentials. That is, Charlie's vaccination shop or Anil's vaccination shop are frankly not authorized appropriate issuers of such credentials. So that bit of infrastructure of certifying and onboarding appropriate health credential issuers, when you think about a global interoperable problem like using health passes, is very critical. And then the other matter, as I've described, the the notion of verification policy. So what are the entry rules? What do I need to show by way of a vaccine or a health status, or my travel history? It may be that if I've traveled through the Federal Republic of Utopia at a period of time, even though I've got a vaccine, I may not be allowed. And so creating infrastructure for appropriate rule setting by authorities, governments being authorities, airports, airlines, really becoming those that implement. With all of this notion of how do you set rules in a multi-party environment is really needed. The notion of a trust framework and operating rules, multiple of those really quite likely to be required to a consistent theme is really what's called for. So really in the next page, it was really through some of this thinking that MasterCard and another number of other companies began to see late last year. We began to see the importance of what we call Good Health Pass, or a global blueprint for Good Health Pass. Some of that was born from some direct conversations we were having with airlines within the airport community. With airlines, a great conversation, and this is really one with Singapore Air, who felt that digital health passes and the inclusive versions of those on paper were really critical for them to get back to travel. And they knew that given every flight they take is an international flight, that they would need to accept multiple implementations of Health Pass, that it could not be the Acme Health Pass company or just the government of the UK or the European Commission that would set, here's either the standard or what the implementation was about. That this was really becoming quite a messy world, and therefore they needed to see health passes that were standard, right? That's what they've kind of told us, and we were kind of on a call and looking at one another and saying, oh my God, there is no standard. Whilst there's great, fantastic work that's been done in the industry at large, in part within the health, identity, air travel, and government domains, it's really not been brought together yet. And so we really had the notion of saying, well, let's not reinvent standards. In a lot of respects, you take a look at work that's been going on in the health community. Great work being done by Linux Public Health and the CCI community, other work in the technology community. There's work within the FHIR HL7 community, a group that's spun up called the Vaccine Credential Initiative, work going on by the WHO. So there's a lot of great work going on there. And then we'll call it almost de facto implementations that are coming from some health pass schemes. So we've got good work going on, frankly, in this community. In the identity domain, which we've talked a lot about today, and I think, wow, Anil, your talk this morning was in the frankly the short period of time, a lot of fantastic content, both about where we've been and where we're at right now. So not much more to really say there. We've also got identity systems throughout countries that have been implemented, and I'd say our recognition that, if someone's not really doing any sort of ID and V at the time I'm getting jabbed, the notion of ID and V later on in the supply chain when I'm presenting a pass doesn't become much better than that. So we have to acknowledge that the notion of multiple zones of identity. Obviously standards within the air travel community, and then both policy and regulation from the perspective of both privacy and other ways in which identity are managed by governments. And so the notion of bringing these together into a cohesive whole, weaving this together by creating a blueprint, we felt was quite important. And so that brings us up to the latter part of last year. And on page 6 that follows, we'll say a view of what we launched in February, what we did launch amongst a group of like-minded companies that now number greater than 100 is a not-for-profit initiative, a push called the Good Health Pass Collaborative. And the purpose of the Good Health Pass Collaborative is to publish an interoperability blueprint. So if we want to get to good, not perfect, obviously needing to be done quick because the pandemic's with us. We need not boil the ocean. We can't afford to be academic. We can't afford to be getting into standards wars. What we've got to do is to get a recommendation for what good looks like in the eyes of a Singapore Air and in the eyes of governments that are applying regulation that are protective of people's privacy and their overall inclusive rights. So what we began to look at were the set of factors that would come to bear in defining what's good. The group was formed, as I've said, at the start of this year. A vision paper was published for this in February of 2021. You could see that paper at goodhealthpass.org. And then as the team of companies that are contributing to this, as I've said, more than 100 endorsing members that have been brought together in multiple working group strands. We've then published an interoperability challenges paper that was published in the latter part of March, and now those work groups are really collaborating to create the blueprint, the detailed definition of what good looks like. The organization has been kindly, in fact, set up and driven by a nonprofit in the U.S. named ID 2020, who's doing some fantastic work in this field, and who have then created partnership with the Trust Over IP Foundation in really pointing to work going on there, both at level 4 and then more broadly using the Trust Over IP Linux Foundation framework for the working group activities, partnership as well within the Linux public health community and the CCI community that Kalia on the call is heading up, and then as well connection into ACI, ICC, and WTTC. So really some fantastic work that we think is going on. We're working to get to some draft recommendations coming up here in another month or so, and I'd encourage any organization who are interested to go to the goodhealthpass.org site for more information and to consider getting involved. This is a matter at the end of the day that it's not competitive. It's not a product initiative. It's really work going on by volunteers within the community to try to make a difference. And very frankly, where we've seen the great work done by organizations like Pfizer and Moderna and others in producing vaccines, I'd say we need to take the challenge to get the IT bits of this right in short order as well. So that was kind of the key message I wanted to pass on. Shiv, if you could just advance the slide. I also wanted to make a bit of a comment in some sense as we begin to see this typical model of self-sovereign of an issuer, a holder, and a verifier, and where they map in. And boy, I've got to tell you, if there's ever a problem set that's facing us yesterday and today right now that creates pull for decentralized identity techniques, it is this problem of Health Pass. Global in nature, many country involvement. You've got to get standard by way of tech. You've got to be protecting people's privacy. And there is no provider on the planet, nor government, nor airline that can solve this on their own. So it ends up saying that a decentralized technique applying to this problem is really, in my mind, one of the first to just scream out and call for this. What I would say on the next slide is that as we've begun to think about this, and Anil really teed up this topic perfectly well, if you recall earlier in his talk about non-negotiable aspects of standards, which we think are very, very key. But the value add bit that we think is important, we'll call it a little bit of the missing link, is to begin moving from what we've seen as the triangle, the issuer, holder, verifier, to a model that brings governance and commercial matters to bear. This is an area that the Trust Over IP Foundation is also doing work at level 4, but it's to begin bringing RegTech functions of accreditation and compliance, dispute management, market making, other value-added services such as complex claims, registry management, and then the migration, the notion that you may need to speak multiple languages to get services off the board up and running are really pretty key. So with that, Shiv, I know we're running long on time. I want to thank you and the other speakers for the chance. And again, the slide set would be shared by the organizers.
Thank you very much, Charlie. This has been very, very interesting. And I think you have highlighted very crucial aspects about the health pass and the travel pass. And I think it's a very noble initiative. And that is why we have joined. But as you said, right, I think we need more people, more organizations to support this initiative because given the pandemic and in general, I think this is a very, very crucial aspect for all human lives and for everybody around the world. So with that, thank you very much for this presentation. And with that, I would like to close this event. Thank you very much for joining in. I hope you enjoyed the conversations, you enjoyed the presentations. We would share the recording with all the attendees. And if you have any questions, please feel free to reach out to us, and we would be able to happily share those questions with our speakers and get those answers back to you. And with that, thank you, everyone. Bye-bye.